In today's lesson, we are going to look at three-dimensional pictures. So they're a little bit harder to see and understand. So here's what we've got. We've got a communications tower is lying due north of Idona's house. Idona walks 1.5 kilometers to Amy's house, traveling 40 degrees east of north. The tower is due west of Amy's house. The angle of elevation from Amy's house to the top is 10 degrees. How tall is the tower? What you really have to try and picture here is that this triangle here is actually flat on the ground. So this is all a ground distance and a ground triangle. So you've got a 90-degree angle in this particular corner. So if you were walking this triangle, you would be walking around on those lines because they are on the ground. But now what you have to picture is this triangle is actually standing up. So this is why it's in three dimensions, because we have a tower here. So you have to think about it going straight up and creating a 90-degree angle with the ground. So that's what you have to try and picture in these ones. So now we can fill in the information from the question. It says Idona walks 1.5 kilometers to Amy's house. So the distance between Idona and Amy is 1.5. It also tells us that she's traveling 40 degrees east of north. So that's where the 40 degrees would be in this particular case. The tower is due west of Amy's house, and the angle of elevation from Amy's house to the top of the tower is 10 degrees. So the angle measure there is 10 degrees. We ultimately want to determine the height of the tower, so I'm going to call that h. But if we look at that blue triangle right now, we only have an angle measure. We do not have any side measures. So the idea here actually takes us back to one of the very first lessons that we did where we had two triangles. We need to find this common side. We need to find that distance. And we can do that using the ground triangle. So if we label this triangle on the ground, we have our hypotenuse. Across from the angle we know is our opposite. And then we have our adjacent. In this particular question, the adjacent doesn't help us. We know the hypotenuse. We're looking for the opposite. So we can use sine, because sine uses opposite and hypotenuse. We know the angle is 40. The opposite side is what we are looking for. The hypotenuse is 1.5. Use your calculator, find sine 40. We get 0.6427. Equals x over 1.5. We want to solve for x, so we can multiply both sides by 1.5. 1.5 times 0.6427 gives us 0.96 equals x. So what we have found is that the measure of this common side here is 0.96. So now we can look at that triangle that's in the blue. If we label it, our hypotenuse is across from the 90-degree angle. Across from the angle that we're given is our opposite, and then adjacent is this common side. So the hypotenuse doesn't help us here. We're looking for opposite. We know adjacent. So we are going to use tan. The angle measure, so the angle at Amy is 10 degrees. The opposite side is the height of the tower. That's what we're looking for. And the adjacent is what we just found in that common side. So now tan of 10 is 0.1763 equals our h over 0.96. We multiply both sides by 0.96. So these will cancel out. And when we multiply those together, we get 0.169. Oh, that's in kilometers, so it's 0.169 of a kilometer. Or if we were to convert that back, it would be 169 meters tall. The question asks us for meters. And what we know is that there are 1,000 meters in a kilometer. So if we multiply that by 1,000, you would get 169 meters. So if you can picture the two drawings and realize that one is upright and one is on the ground, the idea is still the same. We're finding the common side, which then allows us to find the missing piece that we were looking for. So let's look at another one. So Ryan is running an online parts supply business. We want to know what is the longest piece of thin copper tubing he can pack in the box shown. We have to assume that the tubing does not bend. So you think about here, we've got a box or a crate, something. It's a rectangular prism. We want to know what is the longest piece of pipe that will fit in this box. So it is a value that goes from one bottom corner of the box to a top corner on the opposite side. So that is what we are looking for. Now there's a few pieces of information we first have to find. Because right now, if we look at what we would have here, it would be too hard to find that piece of information. Here would be our right triangle. And right now, we do not have two pieces of information in that triangle. All we have is the 30-degree centimeter for one side of that triangle. So we don't have enough information. But what we can do, if we were to look along the bottom of the box and create a triangle along the bottom of the box, we would have a 90-degree angle because we know a rectangle intersects at 90 degrees. We know one side is 45, one side is 125. We can find the third side. This is actually an idea that goes back to previous classes as well. When you know two sides of a right triangle and you are looking for the third side, we are going to use Pythagorean Theorem. A squared plus b squared equals c squared. So that is the first thing we are going to do. The hypotenuse, which is across from the 90-degree angle, is always your c. So that's what we're looking for is d. So we have 45 squared plus 125 squared. 45 squared means 45 times 45. That's 2,025. 125 squared means 125 times 125. That's 15,625. We add those two numbers together. We get 17,650 equals d squared. Inverse of a square is square root. So we square root both of these, and we get 132.8 is the measure of side D. So right here, 132.8. Now we have enough information to find M. Because if we look back at our blue triangle now, we know two of the three sides. And when we know two of the three sides, we can always find the third side using Pythagorean Theorem. So again, a squared plus b squared equals c squared. The hypotenuse is across from the 90-degree angle, so the hypotenuse is our m. So we have 132.8 squared plus 30 squared. 132.8 times 132.8 is 17,635.84. 30 times 30 is 900. When we add those two together, we get 18,535.84. Inverse operation is to square root, so we get 136.1 equals m. So that is how long of a piece of tubing or piece of piping that Ryan could put in this box. Now we're going to add one other little part to it. What if we wanted to find angle theta? So angle theta is in this blue triangle as well. Now that we have found M, we actually know all three sides of this triangle. So technically, we could choose to use any of our three trig ratios. It does not matter. You will get the same answer in all of them. The important thing is making sure whichever ratio you use, you pull the right two pieces of information. So let's label. From the right angle, we have our hypotenuse. From the angle we're given, we have our opposite, and then we have our adjacent. So again, it does not matter which one you pick. Let's say we pick sine. sine is opposite over hypotenuse. So the important piece of information here is to pull the correct two values. The opposite side is 30. The hypotenuse is 136.1. So now we divide those two numbers. 32 divided by 136.1, we get 0.2204. Use your second function sine button on your calculator, and you will get an angle of 12.7 degrees. And if you used either of your other trig ratios, you would get the same answer. So you have now learned how to do three-dimensional problems with trig ratios. So go and practice a few of these.